Right, so I'm Hibri. Thanks to Matt and the rest of the LondonCD gang for having me here. Been meaning to speak at this meetup for a very, very long time, and finally have actually something to say. So this is my story about helping a team to go from literally continuous delivery rags like Stone Age to higher level of maturity, right? So I said I'm Hibri. I'm currently a consultant with Contino, and I help teams deliver faster. So I come from a developer background, and in the past I worked as a lead engineer building public APIs. But I've always had a focus on delivering what I built. So that led me to become more interested in continuous delivery and kind of do DevOps and continuous delivery work now. So this talk is about my experience with the team from about January 2015 to the mid part of 2016. So I was first brought into the company as a continuous delivery consultant, and later on I took over a team as a team lead and lead engineer, right? So a little bit about the company I worked for. It was in the fintech space. At one point it was called a fintech unicorn. It was in the post-startup phase, so they just had loads of money coming from funding, and they were in a rapid growth phase. They still have a very successful product in the market. And when I joined, they had about 30 in engineering. Something to note is that only a couple of engineers had been in the company for more than 6 months, right? The majority of the 30 engineering team had joined within the last like 3 to 6 months. So a lot of the engineering team did not have a lot of history with the company. 200 other employees in compliance, customer support, and so on. So I go in on my first day and go in there eager to sort of put in a CD pipeline and start making things better. This is what I see, right? It's a public-facing API running on .NET in the cloud on Azure. The technology choices weren't too far off the mainstream, so I'm not going to delve too much into the technology details. There was some questionable architectural decisions, but there's absolutely no automation, no TDD, no automated tests running whatsoever. They had inconsistent environments, so I couldn't find an environment which was running the latest code. It was like scattered all over the place. Oh, we need a new environment for the front end guys. We need a new environment for this branch. So there's no consistency. The team was context switching, which meant that they were trying to do too many things at the same time, which led to this, right? Devs would work on a branch and then jump onto the next hot potato, forget the old branch, and then after a while try to go back to the old branch, and then we try to merge it back into master and deal with loads of merge issues. So most of the time they're actually trying to fix their broken merge code, right? So without having any sort of automation test to tell them, oh, that the code is broken, it's quite scary. So this is in 2015. I didn't expect to find Stone Age practices in 2015, especially in a startup. The scary thing I saw was devs were building release packages and over Skype sending it to the ops people to do deploys. So this is kind of what the pipeline or the flow of things to production look like. So I've marked all the automated steps in green. There's no green there, right?
Fabulous.
Yeah. So that's all the manual steps are in red, right? So it's all red. So that's what we had to work with, right? So a lot of you might be in this position, right? What do you fix first, right? Do you go tell people to start working off master? Do you fix any crazy branching strategies? Or do you start fixing the lack of automation, right? Or do you start teaching them TDD, solid principles, design patterns, and all of those things? Or do you just go and put in Jenkins or TeamCity? Like, where do you start? Or do you start working on retrospectives, stand-ups, and things like that, right? So for continuous delivery to work properly, you need little bits of all of these. So it's really hard to pick and choose where to start with. So based on previous work I'd done, I decided that the team has to focus on delivering things to production if they have to improve, right? If that push to deliver doesn't exist, what that leads to is kind of architectural navel gazing. They kind of do work that doesn't have any value for the company or the user, right? And the team just ends up doing kind of busy work, right? They don't push things to life. So with that in mind, I started to figure out what the heck I was dealing with, right? It was like flying a plane blind. No one knew what was going on in production. The team knew production was broken only when the COO started coming out of her office, which was usually after customer support told her that, oh, users are having problems and production is down, right? So by the time the dev team got to know about this, it was probably an hour and a half too late, right? This is what I call a lagging indicator. And when you don't know what's going on in production, that's when people put rules like, don't touch this server. If you touch it, it'll break. So we had to know what was going on, right? This is a really bad place, bad place to be in. So we went to a simple thing. We installed an application monitoring tool. I tend to use New Relic for the .NET stack. It's kind of like my go-to tool when I start working on something. So that's got a zero friction install, and out of the box, I get alerting and PagerDuty integration. So in my second week, I'm getting woken up at home with all the crazy alerts. So that's a simple step, but it gave us it started giving us this. The team could know first when things were broken. They didn't have to wait for someone to tell them. And that's really important because that reduces the management pressure, because the management is not interrupting the team when they're working on something. We started to get a shape of how things were in production, like how much traffic were we dealing with, how many users were affected when there was an outage, what kind of the usage, what the usage trend was. So when we're doing manual deploys, this is kind of important because we needed to know when we had quiet periods, so we could actually do manual deploys and roll back when things broke. Error rates, usually in legacy application there are lots of errors, but you need to kind of need to differentiate what's your baseline versus when things are really, really, really broken. And can this scale? Early on for the API, we could only scale up. We couldn't scale out without doing some serious architectural work. And so once we started knowing what was going on in production, we kind of started to build a shared understanding of the system, right? So I got the team together one day and got them to draw a map of how all the environments on all the different servers that the API was connecting to looked like. Before this, that knowledge was siloed within each individual team members. They weren't working as a team. They didn't know what code the other guy had written. I got them to draw all the components of the system. So that led to the whole team having a shared understanding of, oh, this is actually what we built looks like. Because earlier they were just being handed work piecemeal. They didn't have a joined up thinking of how everything worked. And we kept those maps visible in the team area, so after a while people started to internalize it. So we kind of have better situational awareness. We kind of know where we're going, what we're dealing with, right? And our first evolutionary stage, we haven't automated anything, but we've got a simple feedback loop going from production to the devs, right? So because we had this silo here who were doing the deploys, the devs were just throwing things over the wall. But now they throw things over the wall, but they're still getting feedback of what's happening in production, so they're not completely blind. So a key part of like getting this situational awareness is to sort of expose what the system is actually doing in production, like expose the realities. In a legacy distributed application, I think it's worth changing the definition of legacy application to something that's untested and unmonitored, right? When you don't have tests and you don't have monitoring, you have no way of verifying what your code is doing. You're pretty much like coding in the blind, like, oh, I think it should work like this, but it ends up behaving in a different way in production. So there is no visibility. So with all of that, we kind of got management off our backs a bit, right? They weren't interrupting us a lot. We knew when errors were happening. That gave us enough space to start working on our process, right? They were using Jira, but there's a lot of focus on keeping the Jira gods happy, right? The team wasn't focusing on improving their process, right? Management told them, hey, here's the Jira default workflow, that's your process. It didn't really work for the team. And when they're doing manual releases, there's like a lot of Jira overhead. Oh, go update the release calendar, make sure there's the version number, where the release notes, do all of that. It just didn't add any value. So this is what we did, right? Make work visible with a simple card wall, right? So this also kind of helps create situational awareness about where you are in your delivery process. So instead of having to log into Jira, like open up a browser, enter your username, password, find the right board, all you have to just like turn your head and you know where you are in the delivery process. You know what your team members are working on. Along with this, we kind of play the Jira game a bit because management needed it for tracking, but that was the main way. We started with the pull from the right attitude, so we started to like walk in the board from the right, so we look at finishing work first. Yeah, we used Jira for tracking. So management could now see, just by walking to the team space, what we were working on. We could start having conversations around the wall. So that helped us a bit. And then next, kind of buys us a little more breathing room. We started to limit work in progress. We started doing one thing at a time, and we started to get in the habit of finishing one thing. Like finishing means it's in production and the users are using it, not going to some tester or something. And the whole team focuses on delivering that one thing. There's no, oh, I'm writing code, the testers are testing what was written yesterday. The whole team focuses on, let's all get together, deliver this, and then jump on the next thing. And then once we got better doing that one thing at a time, then we start, oh, let's try simplest thing you can do. Forget everything I said before. Don't do TDD, anything else. If you want to do continuous delivery, just put everyone physically together. Humans have this amazing capacity to solve problems when they work together. You see this when there's a production issue and everyone jumps on the Slack war room, and all these silos just magically disappear. Everyone's kind of working together. So why can't we do that all the time without the extra pressure of a critical production issue? So we were lucky to have everyone in the same area. We kind of sat in the same pod, like around the same tables. And then we introduced Slack after we got better at face-to-face communication. So for the testers, because the whole team was working on one thing at a time, if something broke, a dev was always around to fix an issue. They hadn't context switched to something else, right? So things got fixed and delivered to production very quickly. We didn't ignore remote working. We had something called Virtual Fridays. So even when everyone was in the office on a Friday, we had our headsets on, pairing via Skype, using Slack. We avoided the face-to-face communication. So when someone had to work from home, the transition was seamless, because we had already practiced it in the office. So here we are, feedback loop, still no automation, but the devs and the testers are starting to work together, focusing on one thing at a time. We still had all the other issues. The ops team, we couldn't get them into our team because they were part of another manager's silo. They were shared resource. All the teams had contention around them. So kind of had to live with that for a while. So we created a little bit of Slack, right? And all what I've said previously allowed us to slow down. How did we create Slack time? Got our WIP limits. We've got data from production, so when senior management comes running to us saying, oh, you need to really jump on this and fix this right now, we had data to say, look, only 0.2% of the users affected. It can wait till tomorrow, or you can wait till we finish the current work in progress before jumping on something else. Yeah, have data to push back on management pressure, and sometimes we just told management to bugger off, you know. It's like we had all these headless people with running around like headless chickens. So like we were like, yeah, oh, production issue, yeah, look at New Relic, it's fine, go back to pairing. And getting Slack time is really important because this is where the real long-term change and learning happens. A team learns when they have the mental space to start solving things without dealing with production issues all the time. So this is where we started thinking about automation, starting to think about TDD, and all those good things. So we started our automation journey trying to automate our pain points simply. So we kind of did it tactically. We didn't have this big picture that we need to build up a whole completely perfect CI pipeline. So before we had a CI pipeline, we couldn't reliably build the code. We had only 2 devs who could compile the production release package, right? And if it works on their machine, yeah, it's good enough to go to production. Which means we had a key man dependency to do a release. If they weren't there, we couldn't do a production release. And they only had all the magical NuGet packages and everything installed in special locations on their machine, so the thing would actually compile. We also had this crazy branching strategy in the early days. We had a per sprint release branch, and there were feature branches of that. And then the crazy thing was, if a feature didn't make that release, they reverted the merge commit from the release branch. So in the days of not having an automation, no compilation checks, no tests, that's very, very, very scary. And that naturally led to the team always spending the time in merge hell. It's like they're spending about 30% of the time talking about, oh, where the code was, where did the code go missing? When it all came down to like a silly branching strategy. So we started introducing CI, right? The first step was to get the damn code compiled on a machine that did not belong to a dev. So we spun up TeamCity with just one agent. All it first did was check out the code, compile the Visual Studio solution. That was our first green build. Get a successful compilation. So remove the key man dependency. So now we don't have to wait for someone to compile. Everyone could compile it. And we're still doing manual deploys, but now we kind of have a source of truth for manual release packages, right? It didn't come from a dev's machine who we couldn't trust, right? It came from the CI server. Anyone could go and create the production package for deployment. Still didn't have any sort of testing. We had manual regression testing by the testers, no automation.
TDD?
Automated TDD. In parallel, we started getting our branching under control. So this is kind of a baby step before going to working from trunk or master in the Git world. So we just simply had feature brushes coming off master. When we needed to make a release, we'll just take a release branch. Any hotfixes went into the release branch, and they got cherry-picked back into master. So after things got released, we just forgot about the release branch. So we started getting people stabilizing master. So next evolution, this is where we are. That's how much we've automated, like that bit. So these are like only tiny, tiny changes, but you can see how much they reduce the risk in delivery by taking these small steps. Another lesson I learned, in any chaotic system, there are ways individuals have put in place, like checks and balances, to deal with the dysfunctions in other parts of the system. If not, the whole system would collapse, right? The company would not have a successful product in the market. Something was working. The best place to look for this is to look at the work habits of individual team members. So a key moment for me was finding out that one of our testers had built his own regression test suite. And when everyone was thinking that he was actually doing manual regression tests, he had built his own test library. And he was using that as a no-go for live release, right? So if that was, his word was good enough, and his word came from the test suite he'd written, that would be enough for us to start building our automated tests. So we took his tests, made the tests work in local dev environment. I mean, we had to refactor it a lot because he didn't know BDD and things like that, but he knew the product, he knew the domain. So that was a good jumping point for our tests. So we got those just few tests. They didn't even test the whole system. Made the same test run in all the other environments. And when we got new work, we started adding new tests. We refactored the tests continuously. At first, like, our tests were very, very basic, but as the team kind of started working together, pairing and things like that, we started getting a better understanding of what the product was like, and we rewrote the test to reflect that understanding. And with that, we added automated deploys. So we started to deploy to the test environments on every commit. We used there's a cool feature in Azure called you can run multiple slots. You get it with their paths where you can use it as poor man's blue-green. So you can have a bit of code in what's called a staging slot, and then when you're ready to go to production, you can swap the slot. So the test code becomes live, and if you want to do a rollback, you just swap it again. So the production goes back to the staging slot. So you can have the old version and the new version of your service in the same path. So that was quite useful. We used TeamCity and Octopus Deploy for automation, and because we had the regression test suite, we could now have smoke tests to run after every deploy. So now that was a big jump, because once you do it for one environment, it's quite easy to do for other environments. This last step was manual for a very, very long time, because one of the ops team members didn't want to give us a production credential, and he gave his notice that he wanted to leave the company. And then once he gave his notice, he had a 3-month notice period. He said, "Oh, you can have all the credentials you want." So, like, what took you so long? And then we just in the last 3 months of his tenure, we had fully automated deploys to production going from master. So the other thing I learned all along is not to talk about the A word, right? The A word here is agile. You call it the capital A or a simple A, whatever you call it. It triggers different things for different people. If I point to anyone randomly in this room, this is 2016, you're most likely to have to go through some painful implementation of Scrum or Kanban. So everyone these days has some sort of agile scars, right? I have it as well. So it helps not to talk about the process, but talk about results. Talk about the agile values. Focus on the impact, not how you want to get there. It helps to explain cause and effect, like why do you have WIP limits? What happens when you break WIP limits? Instead of saying Kanban mandates WIP limits and you shall have a WIP limit of 2 or 3, because that just giving a team rules doesn't help them learn. And you got to introduce and repeat the agile principles again and again, right? Things on the left side of the Agile manifesto versus what's on the right. So looking back, after all of that, this book came out later on, the Google SRE book. And I thought this was a good visualization of the journey we'd been through. So we started with monitoring. We got better at incident response. We started using data for postmortems and root cause analysis. We got better at testing and releasing. We had data for capacity planning and whether we need to scale out or more. So all along, we were just delivering software. We still hadn't got to the point where we had to where we started to think about actually delivering value for the organization or the user, right? Because all along, the simple act of deploying software was a burden. Like once you get rid of that burden, then you can start about thinking of how to make the product better, because you can make changes anytime. So this is why I sort of stress the evolutionary approach. It helps to deal with the current constraints the team has. And sometimes it's okay to do things manually. It doesn't say in continuous delivery that you have to automate everything. It's better. And every change you do towards continuous delivery adoption should help the team a little bit more, right? So I could have left the team at any point there, and the team would just be in a better place than they were before. And the whole team should not have to wait for a continuous delivery pipeline built with Jenkins and Docker and the kitchen sink to actually start gaining value. So that's stuck. And finally, you got to have a focus on delivery. Like you need to have that primal need to push out changes and like get your software into the hands of the users. Like that's when you start getting feedback whether things work or not. And to end, thanks for listening.